Okay, today we'll be continuing with section 1.5, which is dealing with solving equations. We'll look specifically at solving rational equations, equations with radicals, and absolute value equations. Of those, the more difficult will be the rational equations that we're going to start out with today. So I've listed a few steps here that we're going to use. We want to start by factoring the denominators if possible. Determine the least common multiple, which is essentially going to be our least common denominator, except instead of getting a denominator, we're going to actually be multiplying by what would be the denominator. So we're going to multiply both sides of the equation by the least common multiple. We're going to cancel those with the denominator, any common factors, solve the remaining equation, and then finally look for extraneous solutions. An extraneous solution basically means you can do all of steps 1 through 5 correctly, and then sometimes the answer that you get just won't work and you need to throw it out. So we may have some domain restrictions that'll cause us to have problems, and we may need to throw those out. Okay, so the first equation that we're going to start with trying to solve is this 3 over x minus 2 over x minus 3 equals negative 12 over x squared minus 9. So looking at our list here, we want to start by factoring the denominators if possible. So this one doesn't need to be factored, this doesn't need to be factored, and this actually factors as x minus 3 and x plus 3. Okay, so our next step here, we want to determine the least common multiple. Our least common multiple is actually going to work the same as our least common denominator. So we're going to have a factor here of x. We're going to have a factor of x minus 3, and then we're also going to have a factor of x plus 3. Okay, so this is our least common multiple. So our next step, we want to multiply both sides of the equation by the least common multiple. Okay, so I'm just going to recopy this, giving myself like plenty of space. Okay, so here we're going to now multiply everything by this least common multiple. So I'm going to multiply it by x times x minus 3. Okay, so I'm going to multiply it by x times x minus 3 times x plus 3. I'm going to do the same thing to this term. So x times x minus 3 times x plus 3. And then I'm going to come over here and also multiply this by x times x minus 3 and x plus 3. Okay, so kind of keep all of these grouped together for the purposes of cancellation. So looking back at our list here, the next step is to cancel with the denominator. Okay, so if I look over here, I can cancel this x and this x. I can cancel the x minus 3's. Here I can cancel an x minus 3 and an x plus 3. Okay, so from here, our next step is that we want to solve the remaining equation. So on this one, I'm left with a 3, an x minus 3, and an x plus 3. On this one, I'm left with a 2x and an x plus 3. Here I'm left with a negative 12 and an x. So I'm left to solve this remaining equation. This one is a quadratic, so I'm going to FOIL this out. So I'll have x squared. Inner and outer are going to cancel, so I'll have x squared minus 9. Here I'm going to distribute. I'll have 2x squared minus 6x, and then here I'm going to have negative 12x. So I'm going to keep going with this, distribute here, and I can see that I'm going to have a quadratic. So with quadratics, we typically want to set that equal to 0. So I'm going to combine these two together and I'll have x squared. I'm going to move this 12x to the other side. So negative 6x plus 12x is going to give me a positive 6x, and then I'm going to be left with a minus 27. Okay, so I have a quadratic here, and I can think about the methods of solving quadratics, which would be factoring, completing the square, quadratic formula, or just solving the simple quadratics. This one actually is going to factor. I need what multiplies to give me 27 and subtracts to give me 6. So that's going to be plus 9 and minus 3. So I'll set each of these equal to 0. and solve. And so I get -9 and also 3. And our inclination is to circle our answer and feel very proud of ourselves and move on to the next problem. The problem with these is we do have one additional step, and that is to check for these extraneous solutions or solutions that cause us a problem with our domain restrictions. And if I were to take this 3 and plug it in, here I have a division by 0 error, and also here. So I'm going to actually have to eliminate this as an answer, and so our answer is only going to be -9. Okay, let's practice with another one of these. The first step is to factor the denominators. These don't have to be factored, so we can move on. The next step is to determine our least common multiple. So that's going to be our x minus 1, our x plus 2, and our 4. So now we want to go in and we want to multiply each one of these by this least common multiple. So I'll have x minus 1 times x plus 2 times 4. I'll multiply that to the 1 over x minus 1. I'm going to do the same thing to the 1 over x plus 2. And then I'm going to do the same thing to the 5/4. Okay, so we're ready to go in and cancel any like factors. So here we have the x minus 1s will cancel, the x plus 2s will cancel, and the 4 will cancel. So if you have chosen your least common multiple correctly, all the denominators are going to cancel and go away, and you're just going to be left with a regular equation to solve with no denominators. So this one, I'm going to pull the 4 out in front. Here I'm left with a 4 and an x minus 1. And then here I'm left with a 5 and an x minus 1 and an x plus 2. So if I distribute here, this will be 4x plus 8. This will be 4x minus 4. Here, this is a quadratic, so we need to FOIL this. So I'll have x squared plus 2x minus x minus 2. If we combine together, we'll have 8x plus 4. Here we'll have 5x squared. These combine to give us just an x. So 5 times x will be 5x minus 10. Okay, what we have here is a quadratic equation. So with a quadratic equation, we need to have it set equal to 0. So I'm going to pull all of this over here. We'll have 5x squared plus 5x minus 10. And then we're going to subtract from that an 8x and a 4. So this will be equal to 5x squared minus 3x minus 14. Okay, the last thing we need to do is to solve this, and this actually does factor, but if you don't recognize it, then go ahead and do the quadratic formula. It factors to be 5x plus 7 and x minus 2. So our solutions are going to be, I'm running out of space here, so I'm just kind of working backwards. We'll have x equals -7/5 and x equals 2. Setting each of these equal to 0 and solving gives me these solutions here. If you check these by plugging them back in, they don't cause any division by 0, so we actually keep both answers for this one here. Again, if you solve this by the quadratic formula, you should still get these same 2 answers. Here are 2 for you to try. So I really, really would encourage you to pause this and take a few minutes to work through these examples and then check your work. It's not the same to watch me do it all the time. You really need to try these. Okay, go ahead and looking at the first example here, or first practice problem. You want to factor your denominators. So this one factors to be x minus 2 and x minus 2 and x plus 2. So your least common multiple would be x minus 2 and x plus 2. And then that's what we're going to multiply each part by. And you can see I've put that in red here so you can tell what's getting multiplied. You can factor the common factors off, and then you're left with a quadratic. This particular quadratic does factor, and then you do end up having to throw the 2 away because it will not work for you with that one. The next one here, your least common multiple would just be the 2x plus 7, the x plus 3. Multiply each part by that least common multiple, and then cancel your denominators. Multiply together what's left. Combine your like terms, and since it is a quadratic, get it set equal to 0. And then from there, if we look at this one, this particular one, it will factor, but it does require the bottoms up method to factor. So if you don't recognize that it factors, use the quadratic formula to solve it. You should still get these two answers as your answer for this one. And again, double check that they're going to work, and they should both work for you. Okay, moving on to the next type that I want to look at today, and that's solving equations with radicals. If we look at the steps for this one, we want to isolate the radical, and once we have one of the radicals isolated at least, and if there's more than one, then you have to just kind of work through that. Isolate one of the radicals, square both sides, and then solve the remaining equation. And again, you do have to check for these extraneous solutions, so be sure that that's your last step, is that you check those. If we look at this one here, the first step was to isolate the radical. So what I'm going to do is I'm going to move this radical over to the left side. So when I move it to the left side, it's going to become positive. And that's going to, and then I'm going to move the 2x over, and I'll have 1 minus 2x. Okay, so once my radical is isolated, we know that to get rid of a radical, we square it. So I'm going to square both sides. I need to do the same thing to each side. So those are going to cancel, and I'll have 2 minus x, and here I'll have 1 minus 2x squared. So I need to FOIL this out. So I'll have 1, the inner and the outer will have negative 2x, and negative 2x will give me negative 4x. And then the last, if I multiply those two together, I'll have plus 4x squared. Okay, this one again is a quadratic, so I need to pull everything over so it's equal to 0. So if I subtract 2 from both sides, I'll have negative 1. If I add an x, I'll have minus 3x plus 4x squared. I don't like to work with quadratics when they're in that format, so I'm going to put 4x squared minus 3x minus 1. And then I'm going to try to either factor this or use the quadratic formula to solve this. Okay, if we're using the quadratic formula, then we're going to put negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So it'll be 3 plus or minus the square root of 9 plus 16 over 8. So 3 plus or minus the square root of 25 over 8, which is 3 plus or minus 5 over 8. When we break this into its two solutions, 3 plus 5 would be 8 over 8. So 8 over 8, and then 3 minus 5 would be negative 2 over 8. So those are reduced to 1 and negative 1/4. So we do want to make sure that when we plug these back in, that we get a true statement. We're not taking the square root of a negative number or something. So if I go and I plug in, if I plug into this problem here, if I put 1 in, then I'm going to have 2 times 1 will give me 2. On this side is going to be 1 minus the square root of 2 minus 1 would be 1. So I'm going to have 2 equals 1 minus 1, which is 0. Then that's not true. So we're going to have to throw 1 away. If I go and put 1/4, negative 1/4 in, then 2 times negative 1/4 is going to give me negative 1/2. And then if I do 1 minus the square root of 2 minus negative 1/4, I'll have minus 1 minus the square root of 2 plus 1/4. Okay, and you can check this on your calculator, but this does equal negative 1/2. So that tells me that this is going to be a solution for it. So always go back and check your answers to make sure that they fit into the original and they give a true statement. Okay, here's another one for us to solve. It's actually fairly similar to the one that we just worked with, but if we go through and solve this, we'll have the square root of 2x plus 1, and that's going to equal x minus 1. Okay, we know that we need to square both sides to get rid of the radical. So we'll have 2x plus 1 equals, and then we'll have to FOIL this out. So x minus 1 times x minus 1 will give us x squared minus 2x plus 1. It's a quadratic, so we want to pull everything over. So x squared, if I subtract 2x, I'm going to have minus 4x. And then here, if I subtract 1, then those are going to cancel. This one actually factors by just taking the greatest common factor out and setting each one equal to 0. All right, so on this one, if I actually go back and check these, then if I put 0 in up here, I'm going to have the square root of, this would be 0 plus 1 would be 1 plus 1, and that equals 0, and that's just by plugging 0 in for both of these x's. So that's not going to be true, so I need to throw that one out. If I look at 4, then I'm going to have the square root of 2 times 4 would be 8 plus 1, and then plus 1, and we want to see if that equals 4. So that's just substituting a 4 in for each of these. So the square root of 9 would be 3 plus 1 equals 4. And so that one would work. So this would be an actual answer for us here. Okay, here's 2 for you to practice and get a little bit more practice with this. Okay, on the first one here, if you square both sides, you actually get completely rid of both radicals in a single step, and you have just a linear equation to solve pretty easily there. Do go back and check your work with that, but you should be fine with that one. Okay, the next one we want to isolate the radical, which means we'll move the 2x to the other side, square both sides, and then you have a quadratic here that you need to simplify. Pull everything over so it all combines together. And then this one actually would factor, but it would be fairly difficult to factor, so you may just want to go ahead and use the quadratic formula, and you actually come up with 2 solutions, and this 21 over 4 is not going to work, so you're going to have to throw it out. Okay, I saved the easiest for last today, and that's absolute value equations. But I would caution you that for some reason people tend to miss these, and it's just simply because I think they are so easy that they don't really pay attention to what they need to do and don't retain it for like quizzes and tests. But because if we took the absolute value of 2, we get 2, but also if we take the absolute value of negative 2, we get 2. So we have basically this 2-case scenario here. So there's 2 different values in here that are going to give us 8 out here. So the way that we handle that is we actually take what's inside this, and the first case we just drop the absolute values. So we have x minus 4 equals 8. The second case, we're going to take this and we're going to stick a negative on the right-hand side over here. So when we do that, we have x minus 4 equals negative 8. So we do one with the positive 8 case, the other one we do with the negative 8 case. And then we just simply solve these two and we get 2 solutions for our answer. Okay, here's another one for us to solve. So we're going to set it up into the 2 cases. The first case is going to be 2x minus 5 equals 3. The second case is going to be 2x minus 5 equals negative 3. We'll solve this by adding 5 to both sides. So that will give us an 8. We'll divide by 2. So x is going to be 4. Okay, on the next one here, we've got 2x minus 5 equals negative 3. So we'll add 5 to both sides with that, and this will give us 2. So x is going to be 1. Just a little helpful hint. You might see a problem that looks like this. Okay, so what's different here is there's a negative out in front. And if you think about it, the absolute value of anything is never going to be -5. So if you see one like that, that's going to be a no solution problem as your answer because there's nothing we can put in here that's going to make that equal a negative out here.